So we have done this with a couple of projects already, and Uport is one of these spokes. A spoke is like from an idea to an own independent company as part of Consensus. We, as a company, our Consensus is, we have 250 full-time employees now. We're roughly 300 people, including some contractors. We have now, our headquarters is in New York. Officially it's in Zug in Switzerland, but we have now more and more offices. We just opened up our office in London and San Francisco. We have one in Romania, Toronto, Dubai will open in 2 months. And so that's we are growing fast and we're hiring, so that's one thing. The team around identity, we are now 20 people. We have already a product, it's not purely paper-based, so you will see this hopefully. And I will now jump into the introduction itself. When we talk about identity and blockchain, there's two different concepts always coming up. One is identity for blockchain, so that's the stuff you likely are more interested in today, and I will focus on this later. Here around this is every interaction with a blockchain requires some kind of private key. So you need to have some way how you know who the other actor is, because whether it's an IoT device or a person or a car, you need to know who the identity of the actor in the blockchain is. That's why it's really important. The key challenges around this is how do you manage keys? How do you know that if keys get lost? How do you know that this identity is back the same identity how it used to be before? And how do you link? I think we talked about mapping on the IT space. In this case, it's more about users, but we're going to expand as well in other areas. So the technology is quite agnostic, but the application I present today is focused on end users. Blockchain for identity. So we're using the blockchain to build what we say a self-sovereign identity platform. Today, identities are always controlled from other third parties, whether it's LinkedIn, Facebook, or your government, whatever. So they all are the authority to issue your credential or an attestation that you are a citizen of this country, that you're a certain age. It's always in the control of other people. And the idea here is that we have now technology which is independent, not operated from individual companies or governments, which can give the user back the control. And that's kind of the connected challenge with this is the ownership of identity, connected to that data, the data to this identity, as well as therefore reputation fragmentation. What that means is you have an account with Uber, with Airbnb, and you build a reputation on each of these platforms. And in each of these platforms you build your strong identity that you're really a great host or something else. And you go to another company or a different service and you cannot really, you start from scratch. You're basically nobody. So the reputation is really fragmented in the current ecosystem. Password management, I think everybody knows that this is a pain. So I will first talk about the second use case with 2 or 3 slides only, that you get an idea that we are working on this as well. And then I focus most of the technical elements on the first part because it's likely more relevant. So I mentioned already it's identities are highly siloed in different departments, governments, and so on. And as I mentioned before, there's a lot of limitation on how you share data, how you can reuse this data. And for user, every time you go to an insurance company, to a bank or wherever, always you need to start from scratch, providing your a scanned part of your driver license or your identity card or something else, maybe utility bill that you can say yes, I really live there and so on. And you do this again and again. You maintain your different data with different sources, and that means also if your credit card gets lost and now you have 20 different web services where you need to go in and again and you start resharing this data. That's kind of a pain, and identity theft, and for big companies it becomes more of a liability to store this data, because if the data breaches, your personal information gets lost and so on. It's it's a big topic. So what we built, as I mentioned, is the self-sovereign identity, and I go to some of the technical details a bit later, but it's really around that the user gets the control of the identity as well as the data around this. We call things like claims and attestations. I can claim that my preferred color is blue. Nobody needs to attest this because that's something I'm supposed to be able to do that myself. But if I'm claiming them older than 18, that's something where we work with third parties who can attest this. And if you do this once or twice or 3 times, and other people or other companies have attested a certain fact about yourself, then you can share this information. And if people trust that this bank or this institution has issued an information and attestation to me, then they can trust and build on that and rely on this for KYC and other things. I keep this short. You can decide where you selectively disclose this information per use case. So it's not anymore that you have this like data silos. You can really share this on demand with services, and see this later. On the right side is more like how we conceptually do this, because this is a technical talk. I will talk about this more in detail later. So what we do, we in our first version have now built a mobile app. As I said, it's more focused on end users, but is relevant, I think, also for some of the IoT use cases you will see. So we are rooted at the moment in Ethereum. So we use the Ethereum blockchain for anchoring the trust, as well as with smart contracts to do key recovery and other things. That comes later. You will see it will be used for like passwordless login. Like you can just sign in and enter any applications, and you see this in a demo. It's user-centric key management, and that's something which is kind of interesting, that key management is really hard. And like, how do you make this that people don't lose their keys? On the other side, keep them secure. So the big challenge is either, or typically in the Bitcoin world, is that you write on your 12-word seed, but you need to keep it secure. If people find it, then they can basically take over your funds, or in this case, your identity. So it's a really relevant challenge, and we have something, and I explained this on the technical side. Signatures, we can sign any kind of like arbitrary data with a signature, basically with a private key, which you can then link to your identity. And then you will see some of the other things in terms of push notifications and transaction cards, that you understand what you can sign. That's all the stuff I will show in the demo. So I think that's kind of more or less a summary of like the different things, like this user-centric identity. And on the right side is how this attestations look like. You have a timestamp. Who is the receiver? Who is the person who gives the attestation? And what is the data someone claims? And then it's signed. So a lot of these attestations are happening off-chain. And there are multiple reasons for this, because many people say, oh, blockchain and identity, you put everything, all your data on the blockchain, and maybe you're encrypted or not. But we don't really store any personal information on the blockchain for multiple reasons, because there's hardly any need for putting anything on the blockchain besides certain proofs. And you will see how we deal with how we manage keys using the blockchain. We are supporting now public and private chains. So the private chain integration is not something we have open sourced yet, but it works today, and I give you one example later. But I think for today, what's important is we support the multiple networks. So we support Rinkeby, Coven, and Robson, but our main, let's say if you start the application, it will use Rinkeby, because it's more reliable than Robson. For that reason, we picked this. We're not yet on mainnet, but we are working hard on going to mainnet soon. But there are multiple challenges to make sure that it works 100%, that people don't lose the identity and the access to this. Just a few words on standards, because building an identity system by yourself, then you cannot really assume that whatever we build, everybody in the world will use. So we are really strongly engaged with a lot of other startups and bigger companies to build a decentralized identity solution which works on standards, which works really across the board. And across Bitcoin blockchain, sovereign blockchain, Ethereum, and others. So we're building with Microsoft, Accenture. I think IBM is going to join soon. There's a bunch of like big companies, as well as like all our peers in the space, working on like data standards in particular, as well as what we call a decentralized identifier, which works across different blockchains. We as well, like this whole credentials, like this verifiable claims that I mentioned, these are data formats which we're working on with the W3C on standards, that this can also like interop with all kind of services. So I will not go through all of them, don't worry. Maybe for what's relevant here, or what many people are more and more concerned about, is this KYC. It does not necessarily need to be like from a finance perspective, but know your customer, that you actually understand, is this person older than 18? Is this person a real person or not? Because in many use cases, people just create multiple identities, and you never know whether that's actually a real person or not. So there's a lot of work where we talk to governments, banks, crypto exchanges, and others who will soon issue attestations to users that they actually are clients, that they're older than 18, and this information is something which is very interesting to use for your blockchain case, because what we are now doing is we're combining this identity for blockchain and blockchain for identity, because now you get this attestation, you can share this with a service provider, with a company, that you can actually rely on this, that's actually the right person. So I skip this. Maybe smart cities is maybe more the one IoT use case. It's really like, how can you build something interacting as a person with all the cities or like services around you. There's obviously digital services, but as well smart locks, cars, buses, everything which is like real identity. That's kind of where we believe blockchain can be a very interesting use case to connect, like you are the owner of this door lock. So now I can grant access through my Airbnb in the future smart contract. I grant another identity the access to my door for like 3 days. And because it's registered in the blockchain, my door could now get a challenge from whoever is coming to the door, can verify that this person has an entry in the smart contract or an attestation that they have access for a certain moment. That's why it's a very interesting use case. I will skip the other stuff. The two examples we were just recently in the press was in Soup. What we did there is you can go to a government, you download your application, you go to a portal, you register yourself, and then you go to the registration office and they verify your data, your birthday and other things, and they issue now attestation to the users. And the users now can take this information and go to e-government services and say like, hey, you have verified me before, this is me, I'm back. Can you please give me access to this, whatever, e-voting or other things. And in Brazil, we had another project. This is more like you upload a document and you can sign it and it will hash a certain proof on the blockchain. And I'll demonstrate this later so you get an idea. In that one, we used public and private chain combination because often we try to convince them like, hey, public chain is much more interesting because then this identity and this attestation you give, people can now use this all over the place with other services. And that's where the interesting part of blockchain comes in, that it's not something which is siloed again. Okay, so the technical part, I will try to keep it high level, but I will be around at least today and tomorrow. And we have some resources on there for people if you have questions. So that's kind of the core concept. So what you will do, if you download the application, it will generate a private key for the user, which is stored in the secure enclave. We talked about this in the morning. It is in the chip on the iPhone, for example. And what it will do in the background, it will generate additional private smart contracts. It will create a controller contract and a proxy contract. And the purpose for these two are twofold. So the first thing is this proxy contract acts on your behalf. So every transaction you send to an application contract is you generate it on the phone, it will sign it on the phone, and then it sends it through the controller, which will check, is this person allowed to use this proxy? The proxy contract will just forward it to the application. So for the application, it's always the same proxy contract interacting with you now. And this is interesting for two reasons. Mainly that you have a persistent identifier, because what happens now if you lose your phone or your key on the phone gets compromised or you buy a new phone, like standard use cases. Yes, you can, of course, in theory, just have a seat and install it on other devices. But then it's kind of tricky because you don't know whether the seat was found from someone else, maybe it's on a different device or multiple devices, and that has a certain security implication. So, and if you lose your phone without doing a backup before, then you're screwed, and all this attestation you collected before, all the reputation you built up is lost. So the abstraction layer of having a controller contract and a proxy contract allows us now that the controller contains logic to recover your key. So an example we demonstrated in September last year already is what we call a social recovery. What you can do is you basically create your identity and you connect to other people's identity and say like, hey, you're part of my recovery network. And you basically pick 5 of your friends, like in a whatever WhatsApp chat group. So you pick 5 people, and then 3 out of 5 can help you to recover your identity. What it means now, if you lost your phone and you have not like stored anything else, you can now contact 3 out of the 5. You get a new phone, you download a new app, and you show this QR code now to your friends. They need to scan this, and then it will pop up. It's like, hey, there seems to be an identity which is not existing yet. Someone needs your help. And then you select, like, this is the person, like, this is Ruven, and I confirm that he's actually the right person. So what it does in the background is then sending transactions to this controller contract, and if 3 out of 5 people have done this, the identity or the the identity will change the access to a new private key. And that allows you to have this persistent identifier. And like the social recovery is just one example. We're talking to some third parties who could provide this. So as a user, I can decide, I want Coinbase and Kraken and Facebook to be my recovery network. Or I want a lawyer in New York State who has accredited or an attestation that he's allowed to do this. So it can be multiple things. So for companies, it can be much more like enterprise style. But for individuals, you can trust other people or other institutions. I don't know whether I need to go into too much detail here, but that's kind of two elements here. There's a device key, this is the phone, and there are multiple contracts in Ethereum. This is just a simplified view, but there are two things which are important for you guys as well, like for the integration now. Every transaction usually requires gas, Ether, for doing any transaction. So what we built is what we call Sensui. Don't ask why. It is a system which gives a certain amount of gas, so Ether, to the user's key, that the user can sign transaction and do the transaction. So at the moment we are funding this. We have some ideas how that looks in the future, but that's maybe offline. So this Sensui allows that the user does not need to be bothered to buy Ether in any form, but can now do transactions with Ethereum, which is kind of interesting. The other thing is, and you see this in the demo, if you have a dApp, like if you have any browser and it's a software running in your browser, how do you connect now your phone? So what we built is just a very simple messaging service which brokers the information between your browser and a phone. That makes it just much faster. This is something which will be open source very soon, so everybody can build his own chassis. So in terms of decentralization, that's all possible. And this one, I think this came as a comment earlier today, we use an Ethereum node which is not running on the phone for like storage as well as battery and other reasons. We're using Infura, which is a service also provided from one other spoken consensus, which is basically you have an API from them and you can send transactions through this to the blockchain and you can read through that. I think I have a link down there that might be quite interesting for most of you if you want to integrate and don't want to run a node on the IoT device. And the rest I think you can skip. So for you guys, what will be interesting, you will see this later in the demo. You can create your app identity. Yeah, so because now all these smart contracts are out there and you see like a very complicated address and you don't know, can I trust this or not? Like I'm about to sign a transaction, I don't know. And you see all these kind of token launches where people are changing the address on the website and suddenly people send money to the wrong address and so on. So this is something I will not demonstrate, but it's a very simple thing and I have some documentations around this, how you can register your own logo for your smart contract so people, if they interact with us, they know they can trust it. All the other stuff, I think I mentioned, the scalable infrastructures, we're building all this like Sensui and all the other infrastructure that a developer can just rely on them. If people feel very strongly about not using push, they can use QR codes and can build up their own infrastructure. Most of the stuff is already open source, not everything, we're working on it. That's the last part for like what's relevant for you to how to integrate this. We have three different types. We have what we call Connect. This is the stuff you install like in your dApp, so you can interact with the user, signing transaction and other things. So that's kind of the part where you will see this in the demo, like read an information, you will share information with the user. The second thing is this credential. So all these attestations, like a lot of the things are happening really off-chain. You use the identity as an anchor, you use the blockchain really as like the trust, but a lot of the information don't need to really be on the blockchain. It makes it much faster and more private and much cheaper. We have smart contracts as well, and they are open source. You can use them, where you can register certain information about the user or your application, and you can use that as well, like as a registry for all kind of information using Uport. So that's kind of the overview. This is our main, let's say, go-to place. At the moment it's on our developer side, so it's developer uport.space, where you get all kind of libraries, information, how you can integrate our chat. And the application now, Uport, is now in the iOS App Store. You can download it. And we have an Android version through that link, or you go to uport.me and request it. So that's kind of the the theoretical part. Now I have a problem because I cannot use my... I need to speak up now because I need to show multiple things at the same time. So the idea is now that I show you, this is my mobile phone, it's live, and I hope it works. So first of all, the mobile app is at the moment more Snapchat style. So what you can see is you register, this is a thing installed on Rinkeby, it's very small. You can see your name and other things you register. Here on the settings you can get all kind of developer information that's all hidden for normal users, like what's the device address. So you see like X85D. Remember this one because that might be relevant for later. And what I'll show you now is, first of all, as a demo, how you can use this from a mobile Safari. So I go to this app, and it's a very simple, stupid thing. You click on Connect with app, and now it wants to jump into the mobile app. And what it does is basically, it jumps into the application and says like, hey, the user wants to log in and give me a certain set of information. So the application can define what information the user wants. In this case, it's a name, phone number, and other things. What you can see here, maybe, I used this 67 times. So that's some form of reputation you start building up that you have not, like you have used this demo already multiple times before. Is it something I can trust? And this count is just the first step to build a reputation on smart contracts. So you click on send, and it will basically send you back to the application. Takes my photo, can also like have my name and other things. In this case, I just wanted to show that briefly, and now I just purchased some shares that you can see how does it look like if you now do a transaction with that. So I click on it, and because it's on mobile, it will ask you again to jump into this, and now it's for signature. So you see now I entered 10, it says update shares. That's depending on how you name the function call in your address, or like in your smart contract. And now when I say accept, now it requests you to sign this transaction. So the private key is on the phone. So when I now use my fingerprint, it will now trigger the transaction and start this. You see now, it's now doing something hopefully. And the transaction, and you see this in a second part of the demo, is triggered in the background. So now, how does it look like from on a dApp? So what we do here now, this is a website where you just integrate our Connect library, and so now that's good. It doesn't work. Enough funding. That's bad. So I don't know whether my transactions work because I might run out of money. So this is how you log in. So you scan the QR code. So there's no connection, like now I'm using my cable to show it, but it ultimately is just a QR code sending an information out to my phone. This reads this, and this is a demo I did last week. So I click on accept, and it will send this information back to the dApp. So there's no other like integration. It's very easy to do this here. So now if I interact with this blockchain, or sorry, with this demo is just to upload a document and hash it in the blockchain. So what it does is now it pushes things up to IPFS, and it might take a few seconds. And I'm not sure whether my funding is now right because it just gave this error message. So it uploads this, and what happens now is it will send a push notification to the phone. So I did not scan a second time because on the first time when I logged in, I already said like, yes, you're allowed to send me push notifications. So now I get this transaction on the phone, and I say accept, and it asks me again for my fingerprint, and now it does a transaction, and I'm running out of funds for some reason. That's what live demos are for. So the idea is it will sign the transaction and send it to the network. And then in this case, it can be any kind of data. We just use a document to upload a file, and then we store the hash of this document in the smart contract. So you basically prove that you have done it. And as a second part of this demo, what I will not do now, is you have a second person logging into the same page, and you can co-sign. So this was something we did for like a notary service, where someone loads something and the second person co-signs it. So now that was not as intended. The same would work on the login with dApps. What we can do, and I will skip this now, but you can send transactions, this attestations to the user as well as like a push notification. And how this all looks like is then on the user's phone, you see all kind of attestations about your name issued now from a certain issuer at a certain time. You can see now verified on a certain time. And that's how you can build up this kind of use cases around attestations from KYC providers and others. So that's kind of the presentation in a nutshell. That's more like start thinking about some of these things. I think some of the topics came up already in the conversation earlier. Where can it help? And that's obviously something we just put some ideas out there. Like we talk to a lot of IoT companies who say like, how can I register like my device? Because as a user, I want to claim this IoT device as mine. So how can you potentially use that interface to say, I'm the owner of it, and therefore it can act on my behalf, or it can sign certain transactions. The other thing is identity for the devices. So instead of using a mobile phone, you can use the same smart contracts and the same libraries to interact now with a device. Of course, you don't need this device recovery potentially, or maybe you do just need part of this. It's all on GitHub. You can see it on documentation. And like building a reputation on an identity. So I think the car example came up earlier. If you are, I don't know, if you do once a day you charge, what does it mean? Who's driving the car? It can over time build a reputation as well. Pay to go, I think, is one of the examples. I think Slockit and others are working on this, where you charge. I think that example came up this morning. Any kind of Ethereum transactions you can use, as you have seen now. Unfortunately, with the bug, with the running out of fund, it didn't work. I think interesting part as well could be that you can use this to trigger an event in a smart contract, which then could have some impact on an IoT device. So an IoT device could trigger the blockchain and see, is something happening? Because I go to a dApp site and say like, yes, please do this. And an IoT device could maybe react on this. And then attestation, so that's the other example where often we talk about IoT devices could do attestations, like sending every minute the temperature of a room or something else, or the location of a GPS device. And that could be something which you can push as an attestation every minute from one of these devices with the security. Yeah. Yes. Yeah, that's kind of the overview, and if you have questions, I'm here now or later.